Yo, I'm Łukasz. 2 years ago, I couldn't write a single line of code. Now, I'm GenAI engineer. Today, I will show you how to make any text model work concurrently, asynchronously, and with autoscaling. We'll use VLM for it. If you ever use other engines like Llama CCP or Olama, it's like having one chef cooking for you one meal at a time. But with VLM, it's like having multiple chefs cooking for you multiple meals at once. Quickly see the requirements. We just need CUDA 12.8. I nearly broke my Linux laptop installing it, so yeah, good luck. This is my driver version. We need just Docker install with NVIDIA Container Toolkit to use your GPU. This is my Linux. And we need to create simple environment. I will use Vent, and I use Bash to show how we do it. So first, we need to have Python 3 Vent, and we create Vent environment. As we can see, it gets created here. And now we just need to activate it. Voila, it's activated. Now we can just quickly upgrade pip. Let's go. And we just install one package, which is OpenAI, because we'll use it to make codes. Okay, so will it get installed? We can look at how we can deploy it. I will use Docker Compose. So we'll create a TTT image, and we use our GPU in this case. If we want, we can use something else. I need HuggingFace token. And to not leak it, I use this variable, which will take it from my n variable that I need to create .env. You can do it by just creating new file in VS Code and do .env. And the example how it needs to look like is basically this. We just provide the name and then the token that we find on the website. So now I want it to be my port 8001. We set IPC to host, so this is important for the parallelism, but we'll not go into detail. I mount my cache volume, so we will load the model faster. I have small model just to provide the instruction. And we have GPU memory utilization. This you typically need to optimize yourself, so you need to basically reserve enough space for the model to load. And then depending on your setup, for the default one, you need to have a bit more left because we want to generate CUDA graphs and prepare KV cache and so on. I will set my max model length to 1000, and max model length is basically the context of the input and output tokens. So if you write a prompt, like write me a poem or story, this will be the prompt. This will be actually the input, and then we add the system prompt. If you add, for example, that you want that you want the LLM to always respond as a pirate, for example. And then the output, so the generation of the text, is what will be generated for us. So I can, because I have installed Docker plugin, it detects my Docker file, and I can just click it run here, for example, and it will start generating it. What you can always do if you don't want to install it, you can just go, for example, to integrated terminal here, and you can just do Docker compose app. And that's it. So in the meantime, this will get generated because much quicker for me because I already prepared it before, so we don't wait. And as we can see, we have max model length of 1000, our GPU utilization. There are other parameters here that we can dive deep if you guys want, but for now I will omit it. And we can see that the model basically loaded. Here it says 8000, but I mark it to 8001. And we have basic routes that we can use to get our messages. So let's jump to the first message. So write simple script when we call our Docker, which runs here, and we'll make a request. And here, if I run it, we can see that first request takes over 2 seconds, which is kind of high. But now I will do it again. And we only get 300 milliseconds. And why it happened? Well, in most of the engines that you use, typically the engine Warmup itself automatically. So during your start, it will run one command to compute CUDA graphs to basically have everything ready when you send a request. In the case of VLM, it don't happen. So you just need to send one request and then leave the Docker or write a script that will just write basically one request. So what we can see here, for example, here I have max tokens, so how many tokens I will generate. And as you guys remember, we set the max model length to 1000 here. So now what will happen if we get 1000 here? Exactly. So because I want to get an output over 1000 tokens, but I already have some tokens here, I basically go over the limit. So if I want it to be work, let's say we want to do 900. And as you can see, the time also increased because I want more tokens, so it takes more to generate the answer, and we get 600 milliseconds. And this is all using async OpenAI. So we make one request in async, and we get this kind of time value. So, for example, I mentioned KV cache, and KV cache is like short-term memory during a conversation. So, like, imagine you talk to somebody, but you forget each response that you make before. So, if somebody asks you some follow-up, you will need to remind yourself of this last response to answer them again, which will take time. And in our case of the VLM, we can see here that we have KV cache usage. And if we go to the first one, yeah, this is auto. So yeah, we basically set the KV cache size to 6,000 tokens. And we have maximum concurrency per 1,000 tokens. So we can make over 6.84 requests at the same time, and they will be computed the same without overhead. This according to this. So now let's actually try it. We'll do even more. So here I have another script where I will basically send questions. So it's our AI generated. So let's do, for example, 7. Or maybe, let's do 7. So we have some simple question here. They're not exactly the same, but as we can see, we can maybe reduce it to the same number of tokens. So at least this will be, So we have 500. So for 500, we get, please don't warm yourself now. Okay. As we see, the model is very funny because it's pretty small. So it's 176. And now I will do, let's say, 7 requests, each with the same number of max tokens. And let's see what happened. Yeah. So now voila. So we get different answers. As you can see, the average response time is 800. Why? Because we send different questions. Yeah. As we can see, sometimes we have much longer answers than others. This is because even though we provide max tokens, some questions can be yes and no, so they will be shorter. But this basically shows you that we make the average response is 800, let's say 880, and then longest one takes 2 seconds. So like in 2 seconds, we get all of these responses back, which is 7. If you make it with standard backend engine, basically we have 7. So we will do, let's do a quick calculation. We have 881, and because it will be synchronous and we do 7, we'll wait over 6 seconds to get all these responses. But here we get it in 2. Now, let's do a bit more and see what happens. So now let's do 10. Voila. And let's see what happens again. So now I do 10 responses, and we get it in just 2 seconds. Before, we can see it was also around 2 seconds. So even though we increase it this much, VLM do like everything to give us responses as fast as possible. We can see how, for example, it happens. So here, it always show us the average prompt to output, the generation to output, and running requests, and how much KV cache is used. So, for example, we see that we have here 0. Here we got 1 request. It depends on the timing, but we can now let's do something much higher. Yeah, so let's do 100 questions that I want to be answered. You can imagine you have multiple tools. Yeah, and see now we have number of requests, because VLM by default have number of requests that in get, it compute them all and then clear them and then get another ones. So for example, here I do over 100 requests to this model, and average response time is 3 seconds because we fill the full queue and then we did the other 20, for example, waits. But in total, it's only 8,000 milliseconds, which is 8 seconds. So like, let's see how much it will take in Llama or Llama CCP. So we have average of 365, and we can multiply it by how many we have. So, too much. So this is how much milliseconds it takes. So now we can, for example, subtract how much it takes in total for us. Of course, technical difficulties. So it's 8213. So yeah, this is our overhead. And now if I divide it by 1,000 to get seconds, we'll wait 300 seconds to get all of these responses on like standard engine. And here we get it in 8. So that's quite a big of increase, basically. So this is what I wanted to show you, that with this simple AI setup, and it's not really that hard, you just need Docker Compose and so on. I will post everything on the GitHub, so you can just copy paste and run it through. You only need to install your drivers on Linux and you are good to go. You can make the calls, you can check basically everything. You can access your docs and see what requests you can make and so on. Like, for example, yeah, this is like this because I posted it on 8001. So this link will always show you inside container, not what you mapped. So if you want, you can just put 8000 here. And here you have various of methods that you can use. Here I have docs. You can, this is Swagger's API from Fast API. So here you have different methods. You can try it out, but I'll not go into details. If you want more details, just post comment down below and I can make more videos about it. The plan is to get us on the text audio transcription locally on like pretty low resources, because as you guys can see, I use small model. And why? Because I'm GPU poor. So yeah, I have a 360 laptop here and I use only this much memory out of my 6 gigabytes. And we can see VLM engine. OBS is also taking some stuff. It's part of the deal. So yeah. So See you in the next one, and drop a comment if you want more, and subscribe. Bye.